mathematical model of a typical thermal process. This is continuously CSTR, continuously stirred tank reactor. A stirrer will be there. That stirrer will continuously stir the tank, continuously stirred tank reactor. CSTR, sometimes it is called CSTR. Here the inflow rate is Fi, outflow rate is F0. The inlet temperature is Ti, the process temperature is T. We have to keep the process at a temperature T. The outlet temperature also T. So it is endothermic process. Means we have to supply heat. The amount of heat supplied here is Q. So many joules per hour or joules per minute. So to heat that process, we are going to use the steam. Steam will entering here and leaves here. So the heat in the steam will be heating that process. The amount of heat given by this steam is so many joules per hour, joules per unit time. This is the coil, through that steam will go. The heat in the steam will be transferred to the CSTR. The height of this tank is H. So now, what is conservation of mass? Inflow rate, total mass, inflow rate, or energy, or momentum. It's true for total mass inflow rate minus total mass or energy or momentum outflow rate equal to rate of change of mass or energy or momentum inside tank. Here we are going to consider energy, rate of change of total energy inflow rate minus total energy outflow rate equal to rate of change of energy inside the tank. Conservation of mass, conservation of energy. So what is total energy into the tank? Total energy entering, total energy leaving the tank. Mass means flow rate, for energy means total energy entering, total energy leaving equal to rate of change of energy inside the tank. So total energy entering is, what is the difference between temperature and heat? Heat, temperature. Heat is energy. temperature is gradient, energy gradient. Gradient means in electrical way, if you want to understand, that is like voltage. Energy is whatever. So heat energy is the difference between heat and temperature is heat is energy, temperature is gradient, energy gradient, like voltage. Here the temperature, inlet temperature is Ti, process temperature is T, outflow temperature is also T. It is leaving at the temperature T. So that total energy entering is total flow rate Fi multiplied by density rho Cp. The heat constant, specific heat constant Cp, rho multiplied by Cp multiplied by energy gradient, that is Ti. Temperature gradient, that is Ti, that gives the amount of heat it brings. Heat means energy. So its unit is what? Rho is kg per meter cube. Cp is so many joules per Kelvin per kg. Flow rate is so many meter cube per minute, let us assume, unit time. Ti is in Kelvin. Here Kelvin inverse getting cancelled, meter cube getting cancelled, kg inverse kg getting cancelled, therefore joules per minute. The unit for this is joules per minute. Similarly, the amount of heat, joules per minute, amount of heat energy leaving is, let us assume that density of entering and the density of leaving is here. Specific heat capacity, Cp also same. Therefore, we can write rho Cp F naught, outflow rate is F naught multiplied by T, that is the amount of heat leaving the tank. It is taking away some heat energy. It is coming with heat energy and leaving some, taking away some heat energy. In addition, we are supplying some heat, so many joules per minute. Joules per unit is what? Joules per minute. So many, this amount of Q amount of heat is supplied. So the first one and this last one is amount of heat entering the system. Amount of heat energy entering the system is the first one. Through this some heat energy is entering. Through this steam some heat energy is entering. That's why both are positive. The amount of heat energy leaving the system is rho Cp F naught T equal to rate of change of energy, that is inside the tank. What is the energy inside the tank? Volume multiplied by volume. Area of cross section of the tank be A. So volume is AH. Rho is mass. If you multiply it by Cp and temperature, you will get heat energy in that mass you will get. So rho Cp AHT has to be differentiated. if you divide on both sides by rho Cp, you will get Fi Ti minus F naught T plus Q equal to divided by rho Cp equal to A d by dt of A is constant, area of cross section of the tank, Ht. That is equal to A d by dt of two variables. H is another variable, T is another variable. So if you substitute A dH by dt, At, if you keep T as constant, you will get At dH by dt plus Ah dt by dt. But we know that from the level process, we know that A dH by dt equal to A dH by dt equal to F naught F in minus F naught. This is the mathematical model of level process. A dH by dt equal to Fi minus F naught. If we substitute that at this instant, let us substitute as such. Later we'll take the nominal level. So Fi minus F naught can be substituted in place of dH by dt. Therefore the equation becomes Fi Ti minus F naught T plus Q upon rho Cp equal to A T Fi minus F naught. Fi minus F naught. Sorry, A dH by dt is Fi minus F naught. That's why there is no A. Tfi minus Tf naught plus Ah dt by dt. This F naught T getting cancelled. Here also one F naught T, here also one F naught T. Both sides are in minus, that's why they are getting cancelled. Therefore, Fi Ti plus Q by rho Cp equal to Tfi, T multiplied by Fi plus Ah dt by dt. Let us assume that this relation is true for changes. We are not going to substitute nominal values. Instead, at a nominal level, it is true for changes means H becomes a nominal value. Fi Ti plus Q upon rho Cp equal to, at nominal level, Fi also nominal, inflow rate also nominal. T Fi nominal becomes constant. Now this becomes constant plus Ah nominal dt by dt. This is true for changes, let us assume. Now the equation is for changes. Now take Laplace transform on both sides. You will get this is constant. What are all constant here? This is Fi n is constant, Fi n is constant, Hn is constant. We are assuming there is no change in level. There is no change in level. This becomes constant. For constant level, we are writing the equation for changes. Now, if you take Laplace transform, what you will get? F in Ti of s plus Q of s rho Cp equal to, we can take T outside, what you will get is F nominal plus Ah nominal s multiplied by T of s. Let us assume that inlet temperature is constant. Inlet temperature is constant. We are going to manipulate Q of S. How we can manipulate? Since Q of S is the manipulated variable. Q of S is the manipulated variable. By manipulating Q, it means by manipulating the steam flow rate. Steam flow rate, we are manipulating Q, we are adjusting T. We are interested in controlling the temperature T. That is the process variable. Here the process variable is T, temperature of the tank. Manipulated variable is Q. So let us assume that there is no change in inlet temperature. There is no change in inlet temperature. Therefore, the mathematical model is T of S upon Q of S equal to 1 upon rho Cp upon A Hn S plus F nominal, Fi nominal. This is Fi nominal. Fi is inflow rate, nominal flow rate. So this is also constant. So we got a mathematical model for manipulating Q. Here input is Q. The output is T. Similarly, let us obtain a disturbance model. In that case, Q is constant. This is constant. Pi is varying. In that case, suppose the inlet temperature is varying. This inlet temperature is varying. Then also T will vary. Therefore, in that case, T of S upon Q of S equal to what you will get? T of S equal to Fin, Fin, not Fin. Fi is inflow rate at nominal, that is constant, upon A H nominal S plus Fi nominal. This is the mathematical model. This is the mathematical model for change in inlet temperature, Ti of S. So that is also affect T of S. The input to this system is Ti of S. This is called disturbance model. This is disturbance model. This is input-output model. Input-output model. So if you combine these two together, suppose both changes are there, then we have to add these two together. You will get total changes. The second one is disturbance model. The first one is input-output model.